So today we are going to talk about quadratic equations and then quadratic expressions as well. And it's a bit broad, so we're going to take our time and then look at it from one step to the other. So this is going to be our outline. We're going to look at the general form of every quadratic equation or an expression. And then we look at a quadratic equation. Oftentimes we find a quadratic equation in terms of x, but then we are going to talk about it in terms of other variables as well. We're going to understand that later. We're going to talk about a quadratic expression and then quadratic equation. We find the difference between the two. And then after that, we talk about method of solving or methods of solving quadratic equations. Then we have a lot of methods, but I'm going to talk about four main methods. First of which is factorization method. So by factorization, that's number one. Number two is by completing the square or the completing square method. Completing the square method. And then number three, we're going to talk about by using quadratic formula. So we're going to, which a lot of people call it almighty formula. So by using quadratic formula. And then lastly, we talk about it solving quadratic equations by using graphical approach. So yeah, we are going to be doing all these things, but then not at a goal, right? So let's start off. What is a quadratic equation, or what do we mean when we say this is a quadratic expression? So we have equations and we have expressions. Let me start with an equation. So any equation of this form y equals mx plus c, or you can write this as ax plus by plus c is equal to 0 or equal to c, right? This is called a linear equation. It is linear because um okay, so let me take off the y and put 0 here, so that I'll call it a linear equation in x, right? A linear equation in x. I'll cancel the by over here, and then I'll say this is also a linear equation in x, and it is linear because the highest exponent, right, of x is 1, which we normally don't write. So for any equation that has the highest exponent of the variable in question to be 1 is called a linear equation. We call it equation because there was an equality sign or equal to sign. If there is no equality sign, we are not going to call it an equation. And we are going to talk about that when we get to expressions. So with the highest exponent to be 1, we call it linear. So the highest exponent is called a degree. So any equation with a degree of 1 is called linear, a linear equation. And then if the degree is 2, so ax squared plus bx plus c is equal to 0. This is so where over here m and c are constant. Over here to a and c are constant. Here a, b, and c are constant. Or there are some numbers that are unknown for now. Okay, so it means that only x is a variable here. So for instance, for this one, we can write, let's put a to be 2. So I have 2 x squared plus b to be 3, 3x plus c to be 6. Okay. So you realize that everything else is a number or a constant except for x. So the highest exponent in this equation is 2, which is over here, right? There's an exponent of 1 here, exponent of 0, and exponent of 2. So the highest exponent is 2. So we say that the degree of this equation is 2. And for any equation in a certain variable whose degree is 2 or whose highest exponent is 2, we call that equation a quadratic equation. And so a quadratic equation is just an equation with a degree of 2, or an equation whose highest exponent is 2. And then if the degree is 3, then we call it cubic. If it is 4, we call it quartic. If it is 5, we call it quintic, and so on and then so forth. So this brings us to our main focus, which is quadratic equations. So now you understand what a quadratic equation is. Just an equation that has a highest degree, or that has a degree of 2, or highest exponent is 2. Right. So for instance, let me write some examples. I have this equation: x squared plus 3x minus 10 is equal to 0. This is a quadratic equation because the highest exponent is 2, or the degree of this equation is 2. So it is a quadratic equation. So we see this, and the variable over here is x. So we see that this is a quadratic equation in x, right? This is a quadratic equation in x, or in the variable x. We can change the variable and let's say write m squared plus 3m minus 10 is equal to 0. This is also a quadratic equation in m, given that m is a variable, right? So the quadratic equation doesn't necessarily mean that all the time the variable in question must be an x, all right? It could be any other variable. But then what makes it quadratic is that the highest exponent of the variable in question is 2, and then we call it a quadratic equation. So it means you can have a quadratic equation in different variables as well. And then if we take out the equality sign, so I'm going to rewrite this and say x squared plus 3x minus 10 without any equality sign, then this is a quadratic expression. Quadratic expression. So an expression is just a group of terms, right? So this is a first, this is a term, this is a term, this is a term, a group of terms, and terms are separated by addition, subtraction, and operation signs, all right? So an expression is just a group of terms without an equal to sign or without an equality sign. And then an equation is one that comes with an equal sign. Right? So you need to understand that there is a slight difference between a quadratic equation and then a quadratic expression. A quadratic expression doesn't have any equal sign, but then a quadratic equation has an equality sign. Right? And then it means that whenever you are posed, you are given a certain question to solve, and you have to make sure you know whether you are solving an equation or an expression. If it's an expression, then you probably are asked to find the factors of that expression or factorize the expression. But then if it is an equation, then you may be asked to find the root of the equation or solve the equation. Right? So there is an expression and then there is an equation. Right? And then a quadratic equation can come in or may come in different other variables rather than just an x. Right? So that is it for quadratic equation. We are going to make a general claim that every quadratic equation, right, every quadratic equation is in this form: ax squared plus bx plus c is equal to 0. So this is for every quadratic equation. So it's in the form a squared plus bx plus c, and where a, b, and c are constant, right? So a, b, and c are always constant, and x is a variable. The degree of this equation is x squared. A is called the coefficient of x squared, b is the coefficient of x, and c is just a constant, right? So a has a special name. It is called the leading coefficient. The leading coefficient, and not just a, but then all the time the coefficient the of every expression or of every equation. You pick the one with the highest exponent and find its coefficient. So its coefficient is called the leading coefficient. So it means that if you had a cubic equation like 9x cubed minus 2x squared plus, let's say, 6 equal to 0, the highest exponent is 3 over here. Each coefficient is 9, so 9 is the leading coefficient. Okay, so a is called the leading coefficient, and the coefficient of the x term that has the highest exponent, and b is the coefficient of x, and c, if we put y here, c will be called the y-intercept. Right? We normally call it the constant, and that's fine. Right? So you should be able to see every quadratic equation in this form: ax squared plus bx and then plus c. So for example, for the example that I stated over there, let me change it and write 3x squared plus 3x minus 10 equal to 0. Let's compare this equation to the general form of every quadratic equation: ax squared plus bx plus c. You realize that a is this is a. A is a number multiplying x squared, right? A is not necessarily the first number, and as a matter of fact, a leading coefficient is not necessarily the first number, but then the number multiplying the term with the highest exponent. So over here, we said a is the coefficient of x squared for quadratic equations. So over here, our a is equal to 3. B is the coefficient of x, and x is here, so each coefficient is 3. So this is our b, and then c is the remaining constant. So over here the remaining constant is negative 10. Don't forget the negative, so c is negative 10 for this expression. Another example: x squared minus 7x and then plus 12 equal to 0 is a quadratic equation, right? If I take out the equality sign, it becomes a quadratic expression. So let's identify our a, b, and c. Our a is the coefficient of x squared. It is one that is normally not written. So the number multiplying or number in front of x squared is a. So over here, our a is equal to 1. B is a number multiplying x or number in front of x. So that's it. So b is negative 7. Don't forget the negative. And c is the constant term, which is 12 for this expression or equation. Now let's add one more example or two. 8 plus 3x squared plus 14x equal to 0. Yeah. So over here, we want to identify our a, b, and c. We are trying to compare this to ax squared plus bx plus c. Let me write ax squared plus bx plus c equal to 0. And don't forget that, like I said, the first number is not necessarily a. For a, we look for the coefficient of x squared. So look around or look through the equation and find x squared, which is here. And so that's the number multiplying x squared is a. So over here, our a is equal to 3. Our b is a number multiplying x. So that is 14. And then c is the constant that multiplies no x, and that is 8 over here. And here again, the leading coefficient is 3 and not 8. The leading coefficient is not the number leading the expression or the equation, but then the number multiplying x squared. So our leading coefficient in this equation is 3. Next example, I have x squared, let me write 2x squared minus 9 equal to 0. We want to identify our a, b, and c by comparing it to the general form ax squared plus bx plus c equal to 0. So look through the equation. Where's our x squared? It is here. So its coefficient becomes our a. So a is equal to 2. Then look through for x, not x squared, right? Because b is the coefficient of x. So we are looking through our equation for an x, and we find no x apart from x squared, right? It means that our b is equal to 0. So if it's missing, then it is equal to 0. And c is the constant, which is negative 9. So it means we can literally write this equation as 2x squared plus 0x minus 9 equal to 0, and nothing changes because 0x remains 0. And lastly, let me do the last one and then we move on to the next thing. So I have 3x squared minus x is equal to 0. We want to identify our a, b, and c. A is the coefficient of x squared, and that is 3. So a is equal to 3. B is the coefficient of x. So we find x here. Each coefficient, 1 we don't write, but it's negative 1. So we include the negative and it becomes negative 1. C is a constant term that doesn't multiply x, and we don't have such thing in our equation. So C is equal to 0. I believe you understand by now, right? You should be able to identify what your A, B, and C are. As you progress, we are going to use such knowledge. You should be able to identify them so that you don't have to struggle, you wouldn't have to struggle when it comes to when you have to identify them and then employ them to solving equation. I'm going to list some examples here. You try your hands on them. You can pause the video, try your hands on them, and then find your values of your A, B, and C. So number one is 5x squared plus 19x plus 12 equal to 0. Number two is 2x squared minus 8 equals 0. Number three is negative 6x plus 3x squared equal to 0. Number four is x plus 6 equal to x squared. So you try your hands on pause the video and then try your hands on number 1, 2, and 3. I'm going to solve the number 4 with you. Right? So number 4, this looks quite different from the ones you've done because there's a term that is at the other side of the equality sign, right? So what you do is that you group all of them at one side, right? We want to express everything in this. We want to write it in the form ax squared plus bx and then plus c equal to 0. So before we identify what is our a, b, and c, we should be able to move everything to one side of the equality sign, and then the other side has to be 0. Right? So what we are going to do with number 4 is that two ways. You can decide to send everything to this side, everything at the left hand side to the right hand side. Right? And that's going to be, so x squared stays there, and then x goes over there to the other side, it becomes negative x. 6 goes and it becomes negative 6, then equal to 0, right? You can write 0 is equal to nothing changes, there's nothing wrong, right? Now we can identify our a, b, and c. Try that, pause the video and try that. So a is equal to 1, b is negative 1, and c is negative 6. I hope you had that one right. That's one way. The other way is that we could have just moved the x squared to the left hand side so that the right hand side becomes 0. So that is going to be negative x squared plus x plus 6 is equal to 0, right? And over here, what is our a? A is the coefficient of x squared, which is negative 1. B is the coefficient of x, which is 1. And c is 6. So you see the difference over here. The values that were negative here, negative 6 and negative 1, they become positive here. And then over here was positive 1, it becomes negative here. There is absolutely nothing wrong with that. Okay? If we were to solve this equation, you're going to get the same answers if you go about by making your a equal to 1, b negative 1, and c negative 6. And I'm also going to get the same answer if I do it's a negative 1, b 1, and then c equal to 6, and then there's nothing wrong. Right? So this is how quadratic equations are. They are in the form ax squared plus bx plus c. Should be able to identify your a, your b, and then your c, as that is going to be very important going forward. So next is to get to the methods of solving quadratic equations, right? So methods of solving quadratic equations. I'm going to, I think I mentioned various methods I'm going to deal with. So methods of solving quadratic equation. I'm going to write quadratics only. And then I told you we have factorization. By factorization, completing the square method by quadratic form, and then graphical method. We're going to do the factorization method for now. So factorization. Okay. So this is what we're going to do. We have, let me give you the steps. A quadratic equation is of the form ax squared plus bx plus c is equal to 0. I'll talk about expressions as well as time goes on. So the first method or the first step is step number 1. So by now I know you are able to identify your a, b, and c. Is find the product of a and c, right? So find ac. Find the product ac. Yeah, find ac. And then step number 2 is that uh, pair the factors of ac, right? And then step number 3, I mean, I'm not going to list all the steps, but then these are things that you shouldn't forget. Okay? First of all, identify your a, b, and c, and after that you find ac, that's a times c. And then the next is to pair the factors of ac, and the next one is you pick. I'm going to end with step number 3 or maybe 4. Pick the factor pair that sum up to b, right? I'm going to explain each one of these, so you don't have to worry for now. So pick the factor pair that sum up to b, and step number 4, you factorize, or you split this, you factorize. So there are a lot of things go into the factorize, this factorize part. I'm going to do justice to that as we go on. So let's start with an equation, a simpler one. X squared plus 3x minus 10. So for now, let's try examples where a is equal to 1, where the leading coefficient is 1. And then later we'll try where the leading coefficient is not 1, right? So first of all, find AC. So you should be able to identify your A, B, and C. So for this one, A is equal to 1, B is equal to 3, and C is equal to negative 10. Make sure you're not confused. Pause the video and then identify your A, B, and C correctly, and then proceed. So the step number 2 is to find AC. Sorry, step number 1 is find AC. So that is A times C. AC is 1 times negative 10, and that's going to be negative 10. But what we're going to do is that, okay, step number 2, let's go there first. You pair the factors of AC. What that means is that we're going to find the factors of negative 10. What we're going to do is that we are not going to include the negative. We're just going to find factors of 10, and that's all. And we're going to pair them. So I said pair the factors of AC. So over here, our AC is negative 10, but we're going to use 10, right? So pair the factors of 10. So let's see. Factors of 10 are, so this is step number 1, step number 2. So 1 and 10. So 1 times 10 will give you 10. And then 2 is a factor of 10, but 2 times what will give you 10? 2 times 5. So you do 2 times 5, and that's the end, right? You're meant to get to half the number, that's all. So that's how you pair the factors, so that it makes it easier when you pair the factors. So if 2 is a factor, what does it multiply to give you the 10? And that's 5. Now the next step is that pick the factor pair. So these ones are the ones I'm calling factor pair. So this is a factor pair, a factor pair. Pick the factor pair, right? That sum up to B. So this is one factor pair, 1 and 10. The other one is 2 and 5. We want to pick which one of them do we add up, or do we subtract one from the other to get B. Remember our B is 3, right? So we want to find out, is it possible to manipulate 1 and 10 by either adding or subtracting one from the other to get 3? If it's possible, we use that. If it's not possible, then we check the other one, 2, 5, right? So is it possible to manipulate or combine 2 and 5 by using an operation sign to get 3? What that means is that, can we ever add 2 and 5, or maybe subtract one from the other to get 3? Right? So that's why the step 3 says that pick the factor pair that sum up, right? So sum up means that we add them or we subtract them one from the other, right? And then the result will give us B. Over here, our B is 3, and then we want to pick which factor can we manipulate to get 3, and that is this factor, 2 and 5. Because, and how do we get the 3? We're going to do 5 minus 2, and that gives us 3. So if that's the case, then we're going to rewrite the equation, the quadratic equation, and then when we get to the 3, the B, you're going to write this as 5 minus 2, because we've split it into 5 and 2. So the next step is factorize, and factorize, this is what goes into it. Rewrite the equation. It's going to be x squared, but then when we get to the 3x, we split it into 5 minus 2. We're going to write plus 5 minus 2. Remember, sorry, 5 minus 2. Remember, we are not doing 2 minus 5, as that is going to give us negative 3. We are looking for how to combine these 2 and 5 to get positive 3, because B is positive, right? So 5 and 2 over here, then you attach your x to them, 5x minus 3x, and then we proceed minus 10 equal to 0. So it becomes 4 different expressions, right? And you see that nothing has been done. The question hasn't really changed, because 5x minus 2x still gives you the 3x over here, right? So what we do is that we pair them, this 2 and then this 2, the last 2. What you can do is that you can do this and then put the other brackets here, right? Or you can decide to push the next bracket over here, right? But you have to be careful as you factorize them. And let's do factorization. What is common to this and this is x, so x out, and then x squared divided by x is x. 5x divided by x is 5. So you realize that when you expand, we multiply the x outside by the 1 here and the 1 here, the 5 here, it gives you the one in the bracket here. Then next is over here. What is common to this 2x and the negative 10 is 2, right? There's no x at the 10 part, but then there's a number that can divide 2 and then 10, and that is 2. So 2 out, 2x divided by 2 will be x. And then over here, negative here times negative. This is where you have to be very careful, right? Negative times negative is positive. So you write plus here, and then 2 goes into 10 5 times equal to 0. Now you see that the x plus 5 in bracket here is same as the x plus 5 in bracket here. That's what identifies that you are on the right track. If you ever get two different things when you're doing factorization, it means there's something wrong, so you have to go back and then make corrections. So because we have x plus 5 and x plus 5 here, we just pick one of them and then leave the other one out. So it's going to be just x plus 5. In fact, we are factorizing x plus 5 out, but then we normally say we pick one and leave the other one out. So after picking that, then you write the expressions that are outside the bracket. So the first one is x and then minus 2. So x minus 2 equal to 0. So this is it. If you expand these two expressions, right, you're going to get the question that was given to us. Now next is 2x plus 5 times x minus 2 is equal to 0. So you write each one of them equal to 0. X plus 5 equal to 0. X minus 2 equal to 0. You move 5 to the other side. So x is equal to negative 5. X equal to 2. So these are the solutions to this quadratic equation, right? The solutions are x equal to negative 5, x equal to 2. What the solutions mean is that we're looking for x values that when we substitute into this quadratic equation, we will get 0, right? We'll get the answer will be 0. And that's why we are solving all these things, and the answers are negative 5 and 2. So you may try that and see that it works. So what the answers are telling us is that when I substitute x equal to negative 5 into this quadratic equation, the result is going to be 0. When I substitute x equal to 2 into this quadratic equation, the result is going to be 0. So the answers are x equal to 5 or x equal to 2. You don't say and, right? You say x equal to 5 or x equal to 2. Let me tell you more about these values. These values are called x equal to 2 or x equal to negative 5 are called the roots of the quadratic equation, right? They're also called the zeros of the quadratic equation. When you get to the graphical method, I will explain to you what these numbers represent on the graph. So the roots of the quadratic equations are x equal to negative 5, x equal to 2. Or the zeros, you also call the solutions of the quadratic equation. So whether the roots of quadratic equation, the zeros or the solutions mean the same thing. Let's try another example. So x squared minus 7x plus 12 is equal to 0. So same method. What is our a? Over here, our a is equal to 1, our b is negative 7, and our c is 12. And once again, you may pause the video and make sure you understand why a is 1, b is negative 7, and c is 12. So let's find AC. AC is a times c, so 1 times 12 is going to be 12. Now let's pair the factors of 12. Let's pair them. 1 and 12, so 1 times 12. 2 is a factor of 12, but then 2 times what? 2 times 6. Then next is 3, 3 times 4. And that's all. So these are the factors of 12. 1, 2, 3, 4, 6, and then 12 is solved. Next is that we want to find out which of these factors can we combine to get B. What is B? B is negative 7, right? So which of the factors can we combine to get negative 7, right? It's not possible with 1 and 12, not possible with 2 and 6, but impossible with 3 and 4, right? We want to get negative 7. So the question is, how do I combine 3 and 4 to get negative 7? I have to make it negative 3, negative 4, right? Or negative 4, negative 3. So we're going to rewrite the equation by splitting the b part into negative 3 and negative 4. So the equation again is going to be x squared. Then when I get to the negative 7x, I'm going to split into negative 3, negative 4, x, then plus 12 is equal to 0. What do we do next? We pair them and we try to factorize each pair. So pair this one here and pair this one here. So what is common to this and this? This and this is x. So x out, x in, minus 3. Then minus, what is common to this and this is 4. So 4 out, we have x. 4x, so we take the 4 out, or 4x divided by 4 is x. And then here again, negative times positive will give us negative. And then 4 goes into 12 3 times. Once again and here again, you see that the terms in bracket are both x minus 3, x minus 3. So we write just one of them, x minus 3. And the ones outside are x minus 4 equal to 0. So our solutions are, the root of the equation are x is equal to 3 or x is equal to 4. And that is our solution to this equation. Now let me explain, what if this equation were an expression? It means that there wouldn't have been any equality sign, right? So the question would have been factorize, or even if the question says solve x squared minus 7x plus 12, this one does not have any equal sign, but then we go by the same approach. Okay, we go by the same method, find a, find c, find the product xc, and then pair the factors, blah blah blah, get to the final. But when you get to this part where you get x minus 3 and then x minus 4, right, at this part over here, we're able to equate each one of them to 0. So for here, I think I skipped a step. We wrote x minus 3 equal to 0, so x equal to 3, which is here. And in the other one, x minus 4 equal to 0, so x equal to 4. What gives us the right to do that is because this is an equation, it is equal to 0. So we needed to equate each one of them, each term to 0, and then we saw. But over here, this is an expression without any equality sign, there's no 0 anywhere. So this becomes our final answer. And these ones are called the factors of the quadratic expression. So these ones are factors. So the question would be that factorize, factorize this expression, factorize completely this expression. And so you work through the same process, but then when you get here, this becomes your final answer without any proceeding, right? You can't equate anything to 0 over here because this is not an equality uh, um, kind of thing, right? It is not a quadratic equation, but then a quadratic expression. So x minus 3 is a factor of this quadratic expression. X minus 4 is a factor of this quadratic expression, and that's how it ends with quadratic expression and then equation. But then there is something quite interesting, right? The first question we solved was x squared plus 3x minus 10 equal to 0. And then our solution to this was, after going through the process, our answer was x plus 5 and then x minus 2 equal to 0, and then we found x equal to 2 or x equal to negative 5. That was it. Then one of the simplest ways to go about this is this, right? And this method works only when a is equal to 1. So whenever the coefficient of s squared is 1, you can go by this simpler method, right? So this is what you do. Because the coefficient of x is just 1, I mean, you can still apply it when coefficient of x is not 1, but then for now, let's learn to apply it for this case. So when the coefficient of x squared is just 1, this is what you do. You open two brackets, okay? Then write x here, write another x here. Now pick the constant c, which is 10. Forget about the negative for a moment, right? And find the factors of 10, pair them. So that's going to be 110 and then 25, as we did previously. Then find which one of them you can combine to get 3. That's 25, right? So it's going to be, how do we combine 5 and 2 to get 3? It's going to be 5 minus 2, right? So positive 5, negative 2. So put plus 5 here and minus 2 here. And we get the same expression over here, right? Same equation. And then we continue the rest. So x is equal to negative 5 or x equal to 2. And then for the previous one we did, the second question, we had x squared minus 7x plus 12, and the answers were 3 and then 4. We're going to do the same thing. Remember, I said try to apply this when the coefficient of s squared is 1. Right? Because the coefficient of s squared is 1, you don't need to struggle. Which open two brackets, got 0, write an x here, another x here. Then find the factors of 12, pair them. Right? It's going to be 1, 12, 2, 6, and 3, 4. Which one do we combine to get negative 7? That's 3 and 4. It has to be negative 3, negative 4, or negative 4, negative 3, any which way. We're going to do negative 3, negative 4. Then the rest is just easy. X minus 4 is equal to 0. X is 3, x is 4. So that's it. Now let's try the third question, but then we are not going to go through the whole process of multiplying a and c and all that. We are going to just use a simpler method. So we have x squared minus 6x minus 16 is equal to 0. Right? So here again, the coefficient of x squared is 1. So we don't need to work any tedious thing. So open two brackets and put your x in there equal to 0. Now the constant term is negative 16, but then forget about negative for a moment. Find the factors of 16. That is 1, 16, 2, and then 8, and that's all. So factors of 16 are 1, 2, 8, and then 16. Now which pair can we combine to get negative 6? Right. Over here, don't forget about negative. Okay? So 1 and 16 will not work. Not possible to get 16. But then 2 and 8 will work. But then how do we get negative 6? It has to be 2 minus 8, right? To get negative 6. 8 minus 2 is positive 6. I want to get negative 6, it's going to be 2 minus 8. So put positive 2 and then negative 8. So our solution is x plus 2 is equal to 0, or x minus 8 is equal to 0. So x equal to negative 2 or x equal to positive 8. And that is our solution. So try your hands on many other questions using this approach. and make sure that you check the coefficient of x squared and it is 1 before you go by this approach. But then it's not all the time that's going to work. Sometimes, for instance, you have a quadratic equation where, let's say you have x squared plus 3x and then minus 5, for instance. Okay, you find the factors of 5 and then they are 1 and 5, the prime number. You can combine it to get 3. Right? So it means that we can't go by this approach, and of course, we can't use the factorization method to go about it. That's why there's a need for even much more methods so that we can still solve questions of this nature if we can't use the factorization method. So next, we'll be talking about the completing square method. Now let's consider examples where the leading coefficient is not 1 or where the coefficient of x squared is not 1. For example, we have 2x squared, use black, 2x squared plus 1 equal to negative 3x. First of all, we need to rearrange these terms. You have to rearrange all the term to one side, and then the other side has to be equal to 0. I'm going to move the 3x right here. So I have 2x squared, and because it is negative, the other side becomes plus 3x, and then plus the 1 here equals 0. Our a is 2, b is 3, and c is 1. So ac is 2 times 1, and the factors of 2 are 1 and 2. It's a prime number, so it has only 2 factors. Now the question is it possible for us to combine 1 and 2 to get 3? Right? Is it possible to combine the paired factors to get 3? And yes, we can get 2 plus 1 or 1 plus 2. If it's not possible, anytime you list all the factors in pairs and you realize that none of them can be combined to get the value of b, it tells you that we need to find different methods of solving the question. It means that the factorization method will not work in that case. In this case, it works, so we're going to rewrite the question. 2x squared plus, but when we get to the 3x, we're going to split into 2x plus 1x, which is the same as x, and then plus 1. Of course, there's nothing wrong if you want to write 1x before the 2x. There's nothing wrong. So let's pair them. The first two terms paired, the second term, two terms also paired. Now for the first term, you find out what is common to the two terms, 2x and then 2x squared. So 2 is common to them, x is also common, so 2x is a factor. 2x out of this, we have x left, and then over here 2x, and you factor out 2x, so you have only 1 left. Then the next one, it looks like there's nothing common to both of them, but then this is x is the same as 1x. Okay, so what is common to both of them is 1. Anytime you realize that there's nothing common, remember 1 is a factor of every number, equal to 0. Now we see that the ones in brackets are the same, so you write only one of them, x plus 1, and then 3x plus 1 equals 0. And we can write each one of them and equate them to 0. 3x plus 1 equals 0. Over here we have x equal to negative 1. Here we have 2x equal to negative 1. Divide both sides by 2. So our final solution, x equal to negative 1 or x equal to negative 1 over 2. Those are our solutions. So this is a quadratic equation, so we expect to get values of x. If it were a quadratic expression only, for instance, if the question only ended here, with only 2x squared plus 3x plus 1 without any equal to sign, then we would have been asked to factorize. In that case, our final answer would be just this part, without any further equating anything to 0. Let's try one more example. 5x squared plus 19x plus 12 equals 0. So identify your A and C. A is equal to 5, B is equal to 19, and then C is 12. Our AC is 5 times 12, and that is 60. You're going to list all the factors of 60. You're going to pair them. So let's list the factors of 60. We have 1 and 60. 2 is a factor of 60. It is 2 times 30. 3 is also a factor, 3 times 20. And then 4 is a factor, 4 times 15. So the factors of 60 are 1, 2, 3, 4, 15, 20, 30, and then 60. Then we find out from the factors which one of them can we combine to get B. Over here, our B is 19. So we're looking for which factor can we combine to give us the 19. And if it happens that no factor can give us the 19, it means that we can't proceed with this method. We need to use other methods. But you realize that the last factor 4 and 15 can be combined to get 19. So 4 plus 15 or 15 plus 4 will be 19. We're going to solve it by rewriting the question. 5x squared, and when we get to the 19x, we write it as 4 plus 15 or 15 plus 4 plus 12 is equal to 0. Now next is that we pair the terms. So the first two terms paired, the second two terms paired. And you factor out what is common to each bracket. So for the first bracket, 5 is common, x is also common, so 5x is a factor. Now out here we have x plus 15x divided by 5x is 3. And next we factor out 4. X 12 by 4 divided by 4 is 3. So we see that the ones in bracket are the same. And then so you write only one of them and write the ones outside the bracket. X plus 3 is 1, and then the outside brackets are 5x plus 4 equal to 0. So we write each one of them equal to 0, x plus 3 equal to 0, or 5x plus 4 equal to 0. Here we have x equal to negative 3, or x is equal to negative 4 over 5. So these are the solutions, or the zeros, or the root of this quadratic equation. So try your hands on this. Make sure you get the answer right. 3x squared, so number 3 for your trial, plus 14x and plus 8 equal to 0. So you take your time, you solve, you're going to get x plus 4 and then 3x plus 2 equal to 0. Your answers are supposed to be x equal to negative 4 or x equal to negative 2 over 3. Make sure you take your time, you solve it, and you get the answer right.